So the last formula that the textbook introduces us to is a formula for earthquakes. And the formula for earthquakes actually has a log in it. All of our other formulas so far have had exponents. So if you wanted to solve for the exponent, then you needed to use logarithms. But this is the first formula that has a logarithm in it. So what do different things stand for? Well, m is the intensity of an earthquake. And if you've heard about earthquakes, and most people have, right? You've probably heard of what, but how they work, right? They tell you, oh, it was a 7 on the Richter scale. And then the next one was an 8 on the Richter scale. And probably somewhere along the line, you learned the difference between a 7 and an 8 with an earthquake isn't just, oh, it's 1 bigger. It means that it was 10 times more intense. Every time you go up by 1, the intensity goes up by a factor of 10. So if you were comparing a 6 to an 8, an earthquake on the Richter scale of 6 compared to an earthquake on a Richter scale of 8, the 8 is 100 times more intense than the 6 was. And moving backwards, so there's actually, if you look it up, there's earthquakes happening all the time on the Earth, but usually they're not very big, and they don't make a big impact. But when they get large, just because the intensity goes up so much, then we hear about it. So, the magnitude of an earthquake, m, is log of I over s, where I is the intensity, and s is a standard earthquake. So for these questions that we're going to be doing, this is the one situation where sometimes we're going to use the formula, and sometimes we're just going to use the idea. Like if we're comparing two earthquakes, and we went from a 3.3 to a 4.3, well, it's gone up 1, so it's 10 times more. If you went from a 3.3 to a 4.8, you went up 1.5, so it will be 10 to the 1.5 times more intense. So we'll look at the question. The most intense earthquake ever recorded was a 9.5 in 1960. Calculate the intensity in terms of a standard earthquake. So again, on an exam, you would be given the formula. And each of the things would have been given and explained to you. Now, in this question, the magnitude is 9.5. So we could plug that in for m. And we want to solve for I. The s part is a standard earthquake. It's like a number. It's just a constant. We're not really, we're just leaving that in there as part of the equation. So right now, we want to get I by itself. We want to solve for I. So we have to go back to our skills in solving logarithms. We solved exponential equations where you had to take the log of both sides. That got the exponent out. But we also solved log equations. And the number one thing for solving a log equation is to get a single logarithm and then to change it to exponential form. In this example, it's already a single logarithm. Can you see log of something equals something? And just to maybe cause your memory, remember I always put it like a green asterisk because I said this is the step you're going to forget. Well, this one, the next step is where you have to use the definition and change it to exponential form. What's the base? The base is 10. What's the exponent? 9.5. What's the inside equal to? I divided by s. And so if we wanted to solve for I, we would just have to multiply both sides by s. So we have solved for the intensity in terms of a standard earthquake. In other words, the intensity of this earthquake is 10 to the power of 9.5 times bigger than a standard earthquake. If you do 10 to the 9.5 on your calculator, oh my goodness, how do you even say this number? Here it is, 3,162,277,660 times more intense. That seems like a lot. Part B. Calculate the intensity, part B. How many times as intense as the Haiti earthquake, which was in the example before, which had a magnitude of 7. So we want to find how many times more intense was the Haiti earthquake, and give your answers a whole number. Now there's two ways to do B. I'm going to do part B without the formula in sort of an easy way first, and then I'll show you how the formula works. So what we're trying to do is we're trying to compare them. And we've got the Chile one as 10 to the 9.5 and the Haiti one as 10 to the 7.0. Can you see that from 7 to 9.5 you've gone up 2.5? And every time you go up by 1, it's 10 times more intense. So if I just simplify this, I get 10 to the 2.5. And if we do 10 to the 2.5 on our calculator, we get 316 times more intense. Now, if you wanted to compare the intensities using the formulas, okay, what you're really doing is you would need, we found the intensity of Chile. I'm going to put a little C there to stand for Chile. We found that that one was 10 to the 9.5 times a standard earthquake. You could do the same thing for the Haiti one, and you would find it to be 10 to the 7.0 times a standard earthquake. And if you're wanting to find out how many more the Chile one was Haiti, well, intensity of Chile divided by the intensity of Haiti would be 10 to the 9.5 times S divided by 10 to the 7.0 times S. And you can see why the S's really don't matter. They would just cancel each other out. And you'd get the same idea that you're going up by 2.5. So most people just prefer the shortcut. They know for earthquakes, whatever number you're increasing by when you're comparing, it's going to be 10 to that power as the difference. And on your final exam, if you don't use the formula for that, they're perfectly fine because you have an understanding of how earthquakes work. So questions we can do for practice with earthquakes. 4, 5, 9, 10, and 11.